when we dealt with transformations of lines and absolute values. The parent function in this process now is f of x equals x squared. And those same shifts, vertical and horizontal, are the oranges if it's a positive k, it moves up. When it's a negative k, it moves down. Horizontal is left and right. Be careful on those. Remember, that's inside the function. You have to think opposite. Then we have our reflections, our vertical stretches and compressions, and our horizontal stretches and compressions. Don't write this slide down. All right, let's go ahead and graph our parent function for this parabola. So remember, f of x represents the letter y. So we're going to substitute some values in for x to get our y. So let's start with 0. So we're going to substitute 0 in right there. So 0 times 0 is 0. So our first order pair we graph is 0, 0. This is going to become a very important number down the road. This is what we call the critical point, or the vertex of the graph. Now let's go and plug in 1 into the function. So 1 times 1 is 1. So now we graph over 1, up 1. And now choose 1 to the left, negative 1. Be careful on your parentheses. Negative 1 times negative 1 is 1. So we're going to go left 1, up 1. Now let's choose 2 and negative 2. 2 squared is 4. Negative 2 squared is 4. Notice what starts to happen. We see repeats as we move 1 left, 1 right. So over 2, up 4, left 2, up 4. So here is the start of our parabola. This is called your vertex. It is the minimum point on your graph in this case. This is the parent function. We are going to have transformations that occur. Again, that's referring to that last slide of all the changes that could happen. All right, describe the transformation and then graph it. So we're trying to now move away from the traditional XY chart that we did on those last couple examples. So the original parent function is f of x equals x squared. Two things are going on in this problem. We have a minus 3 inside of the function, and we have a plus 2 at the end of the function. So let's talk about the plus 2. The plus 2 moves the graph up 2 units. And then the minus 3 inside of the function, that's where we have to think opposite. It's going to move it to the right 3 units. So let's graph the original parent function first. So we just did that on the last slide. So there's 0, 0, 1, 1, 2, 4, negative 1, 1, and then negative 2, 4. So there's our original parent function. Now let's apply the transformation. We're going to move that vertex right 3 and then up 2. So here's our original 0, 0, our critical point. So we're going to move it to the right 3 and then up 2. So where does that put us then? 1, 2, 3 units to the right, and then up 2. So our new vertex is positive 3, positive 2. Now we just repeat the pattern. We're going 1 right, 1 left, and then remember what happens when you move 2 to the right and 2 to the left. Now we're going up 4 units from the vertex. going to change colors just to keep it a little easier to see. So we'll make that g of x. There is my vertex. Moving right 3 and up 2. How you describe it is the graph shifts right 3, up 2. Next example, describe this transformation and then graph it. So again, the original parent function is f of x equals x squared. What happens is it's minus 2. So that's at the end of the function. So it's going to go down 2 units. Is describing the transformation. So let's graph that original parent function again and see what happens. Vertex 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Now we're going to pick up the blue graph and shift it down every point 2 units. So this original 0, 0 is going to be here. This 1, 1 is going to be down 2 units, down 2 units. And now this 2, 4 is going to be down 2 units, down 2 units. And now here is my new g of x function with the transformation. Last example, describe the transformation here. Now we have a value in front of the function that is multiplying. This is what we call a vertical stretch. So we are doing a vertical stretch by a factor of 3. So think of it as stretching your graph parabola up. So it's going to make it taller, or what we call skinnier. So let's graph the original parent function again. And you won't necessarily have to do this every time. I'm just doing that so you can kind of see the difference between the blue graph, the original parent function, and our transformation with the red one. So now think of this as 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. That's the original parent function. Now think about taking those numbers and stretching them, multiplying them all by 3. So what would that chart look like? Well, if I multiply 0 by 3, I still get 0. If I multiply 1 by 3, this ordered pair is now going to be 1, 3. This one is going to be negative 1, 3. And what happens when I go to the next one? 4 times 3 is 12. And now let's graph those. So I have the same vertex, 0, 0. And now I'm going to go right 1, up 3. And then I'm going to go right 2, up 12. I'm a little bit off my graph, so let's go up here. Here's 12. So right 2, up 12, and then left 2, up 12. It's vertically stretching it up by a factor of 3. Now, you could have more than one transformation on the graph. Sometimes it could be a reflection, an up or down, a right or left, stretches and compressions. Here is our homework for 5-1, day 1, page 320, 1 through 7, 20 through 25.